Okay, so you guys have a drawing that kind of indicates is a model. All this is a model, and it's not a very good model once we figure in doing all this other stuff, but it gets us a start. And this model shows different levels, and those levels are called principal energy levels. You should have that written down. Okay? So they go 1, 2, 3, 4, and continue on if they're needed. Okay? If we get more and more electrons if they're needed. So we have this idea called the principal energy level. And it's indicated with the symbol of a little n. So in the future, we'll say n equals this, and we'll know what level it is. So we say n equals 4, we know it's the 4th level. If we say n equals 7, we know it's the 7th level. And those are energy levels. They indicate the energy of the electron. Okay? So as we go to 1, to 2, to 3, to 4, and so on, the principal energy level numbers always positive integers. Okay? So they'd be 1, 2, 3, 4, 5. And as this proceeds up from 1 to 5, the energy increases. So if we compared, remember I said we're going to be able to tell a little bit about electrons and some properties they have. So an electron in the 2 compared to an electron in the 1, how do their energies compare? 2 has more energy than 1. Now, we can actually calculate that. We're not ever going to do that, but in AP chemistry we do calculate what that's going to be in relationship to one another. Because there's a formula that you can use to calculate it. And you're not going to do it. Okay, so now, so that's the energy levels, and as you go up, you're going to get more and more electrons in each energy level. So as we go from 1 to 2, it's like going up in size of your house. Like when I first started out teaching, it was me by myself, and I had a trailer. I had a trailer for a couple months, okay? Small trailer. And so then get married, you need a little bit bigger space, and you start having kids, need a little bit bigger space, and that's what electrons are at. If they get more and more electrons, you need a bigger space. And you can see as you go from 1 to 2 to 3 to 4, you get bigger spaces that they can hang out in. Okay? They're not so constricted. And we'll find out exactly how many electrons can be in each level, and I'll give you a formula to determine that. You can figure that out. That'll tell you the max that can be in each level. All right? Now, what I'm going to introduce to you today is that within every level, there's a sub-level. Okay? So we have these things called sub-levels. Now in the past, I used to give a symbol for this, and it used to be L. But I'm not going to give it to you. Like principal energy levels N, sub-level would be an L, but this book doesn't go through it to that extent. So the sub-levels, like principal energy levels is 1, 2, positive integers. The sub-levels used to be explained as 0, 1, 2, 3, 4. The 0 would be a particular type of shape. The 1 would be a different type of shape. We don't do that. We tell you that these sub-levels make it more sense, so we're not dealing with numbers. We will say it S, P, D, and F sub-levels. That's how many sub-levels we have. S, P, D, and F. So we can label an electron with the principal energy level and then give it a sub-level that goes with it. So I can say 1s. And you know that electron's where? In the first level. 1s. So you're saying, well, what's the S mean? I'll tell you here in a second. Or I can say 3D. Okay, so what level is that one in? It's in the third level. Okay, or I can say 4F. And we know it's in the fourth level. Now, I cannot say 2F, because the F's don't come in until later. So this is a sequence. It should go S, the second level picks up a sub-level. So every level picks up a different sub-level. So S, SP, SPD, SPDF. So we pick up a sub-level every level. And that allows us to have more electrons. So the first level can only have an S sub-level. Second level can have a combination of S and P. So that's why I cannot say 1D. There's no such of a sub-level that's D in the first level. I'd have to go to what level before I get the Ds? The 3. Okay, can we have a D in the fourth? Yeah, we can have a fourth. Can we have one in the fifth, you think? Yeah. Okay, S's can be in every level. S's are in every level. So S's are in first, second, third, fourth. Okay, now I'm going to tell you something about the sub-levels as well, is that each one of these represents an increase in energy as well. So if I compare a 2S and a 2P, which one's going to have more energy? The 2P. 2P has more energy. It's kind of like diving. If you've ever watched diving or been to a competition of diving, they have different levels of difficulty. And if you do a good dive in a certain, one of those levels, they have multipliers that multiply your score. So, I don't know, what's the max? 6? Is 6 the best? Okay? So like if I got a dive and they hold up 5s, then there's a multiplier that says that 5, if it's a really, really difficult dive, it would be maybe multiplied by 2.2 versus a regular dive that might be multiplied by 0.8 or something like that. So as you go up, these energy increases with them as well. So you can compare two different electrons in the same level and know that a 2p has more energy than a 2s. So the F would be the most energy associated with the sublevels. Any questions with that? All right. So question is, what does S represent? It indicates the type of shape of the orbital. Here's an S. Okay? So if you had to describe that name, you would say that what kind of shape? Sphere. Sphere. Okay? Sphere shape. And so it's three-dimensionally. You can see it three-dimensional shape. The x-axis and the y-axis is kind of going through the center, so we know it's in the nucleus. So that would be an S shape. The sub-level S tells you the pathway the electron is going to take. Okay? Or its shape. So there's the shape. And that's what it tells you. So an S is a sphere shape. Okay, now I'm not going to show D and F. I think they might show them in the book, but I'm not sure if this text they do or not. The P, no. The P shape is a dumbbell shape. That's the P shape. Okay? So it's a little bit more complex. You've got to realize is these. And it's hard, it's based upon a mathematical concept. So these are really hard to symbolize with a model because they're a mathematical probability of where the electron is going to be located. It's called a probability. Electron's located anywhere within that shape, okay, of where the rubber part of the balloon is. That's where the electron is going to be located. So the P shape is a dumbbell shape. Like that. And then the D shape is, you can look in the book, I'm not going to draw those, they get a little bit more complicated in that. And you can kind of see why energy would increase to be in those different shapes. Okay? Questions you have up to this point in time. All right? So, principal energy level tells you the location in energy. If you put it with the sub-level, it tells you its energy related to electrons within a level. A 2p is more energy than a 2s. Okay, we also realize where these sublevels can come in, and they come in sequence of 1, 2, 3, 4, which would be S in the first, P in the second, D in the third, and F in the fourth. Now, we don't have any past that. In theory, we could. In theory, we could keep going on, but we don't. We have so many electrons to deal with, and when we run out of those sublevels that we have to deal with. Okay, so that's all I'm going to go through today with you, but I'm going to give you an idea why we can have more electrons in each level, because each level of S's can only have one type of S orbital, one type of pathway it has. Okay, so when they first built the school, we only had one pathway in and out of the school. You guys know that? You guys probably don't even remember that, do you?
Nope.
We never did have this exit over here with the bumps. Okay?
Oh.
We only had one in and out, and it was a stoplight.
I think you don't remember it.
Okay? So that was the only in and out. So they found out right away, wait a second, this is when we had a lot more students than we have now. Okay? And they realized, wait a second, this isn't going to work, so they did an alternative exit. Okay? That you can go in and out. So, this is like one exit. Electrons can only be in this orbital, and we can only have two in an orbital. So, the S can only hold 2 electrons at any time, at any level. S's can only hold 2 electrons at every level. So you're like, wait a second, there's 90-something electrons. Where do they all go? Now the P allows more electrons. Each of these represent an orbital. So how many electrons can fill this orbital? 2. Okay? How many can fill this orbital? 2. How many can fill this one? 2. And then this one can be 2, right?
1.
There's one orbital, but it represents one orbital, but it can hold 2 electrons. Every orbital holds 2 electrons. We have different shapes that the orbitals take. Okay? So when we look at the second level, then this is why we can fit 6 into the P sublevel, because it can have 3 different ways in which it can travel around the nucleus. See the 3 different ways? The nucleus is in the center. Right? Nucleus in the center. So we can have 2 going this way. We can have 2 going this way if it's full. We can have 2 going this way, which is a total of how many? 6. This can only hold 2. Let's look at our example up here. So how many electrons can fill the first level? 2 electrons is all. And I'll write 2 electrons. Okay, now we got the second level, which is S's and P's. How many total electrons? 8. Guys, count across the first row on the periodic table. How many do you have?
2.
2. These 2. Hydrogen, helium. Count across the second one. How many do we have?
1, 2, 3, 4, 5, 6, 8.
8. 8 electrons. Okay? Now, the third, and I haven't got to the D's yet, and we're going to get to those not today, maybe tomorrow a little bit. We're going to stop there. Okay? Now, I'm going to give you, without getting into the D's and F's, I'm going to give you 3 equations, okay? And based upon N. Okay, N is the number. So I'll put 1, 2, 3, 4, 5, 6, 7 in for N. And then you can tell 3 things using these formulas, okay? So this is the last bit. And I'm not going to rewrite this. So, if we know N, we know how many different sublevels are in a level. So if I say 3, how many different sublevels are within that level? 3. And they're SPD. If I say 4, then how many different sublevels do we have? 4. SPD. F. If I say 1, there's only going to be S's in the first. N squared. What does that tell you? It tells you how many different orbitals you can have in that level. S. So if I put 1 squared is what? 1. It only has 1 orbital, the S. If I say 2, 2 squared has how many? 4. You guys see the 4? Okay. Now if I, without getting into D's, if I say 3, how many different orbitals can the third level hold? 9. 3 squared. Does that make sense?
Oh, yeah.
If I say 4, it'd be 16, right?
Yeah.
16 different orbitals, each holding 2. I've only did the S's and P's. I'm not showing the D's. I can't show the D's. I can't show the F's. We'll get into those, a little bit more information about the D's and F's tomorrow or Monday. Okay? 2n squared. All I'm doing, I know that each orbital holds 2. I'm just multiplying it by 2. So this can hold 2. Each one of these can hold 2. So if I say second level, how many electrons can fill the second level? You would say 2n squared is 8. How many can fill the third level? 18. 3 squared, 9 times 2 is 18. Count across the fourth period on the periodic table. How many elements do you have in the fourth period? 18.
18.
Okay? Now this one's going to take a little bit more counting. I don't know if some of you guys can count this high, but we'll see. Okay? The fourth level includes 55 through 71, picks up here at 72, all the way over to 86. How many elements are there? Okay, but 32.
Nice.
So if you go 4 squared,
I'm guessing it's 32.
yep, it's 16 times 2 is 32. Okay, makes sense? You guys can really use your periodic table to help you identify electrons and where they're located at. Okay. Questions? All right. I encourage you to read through section 5.3. It's about 3-4 pages that goes through a lot of this. Plus it goes into D's and F's, which we'll go through on maybe tomorrow, maybe Monday. Okay?